Thank you for coming back. So today, I'm going to try to talk about two things, depending on time. I'm going to talk about daylighting and some of the fundamentals on daylighting, some of the technologies, some of the experimental work we're doing. And then if I have time, I'm going to touch on the retrofit initiative that I'm working on at Davis. Maybe we bring the lights up just a tiny bit because folks will start going to sleep. Maybe just a little bit more on the lights. Just a little bit of light. Sorry. My experience is that if you have students watching a presentation in the dark, so that's good, thank you. So I'm going to talk about sort of a combination of current research and policy in daylighting. Oh, Jesus. Need glasses. Had it backwards. So the importance of daylighting. Well, what are the sort of the big drivers on this? And you can really simplify it down to two things. One is daylighting saves lots of energy, and people like it. So it's pretty straightforward. You don't need a lot of fancy policy for this. It's a huge energy saver. People just love it. Okay. From what we can tell, most building types that we build and we habitate, it's about 80% of the building stock. Just as a rough estimate, we can use daylighting as the primary illuminant. And so you sort of have to ask yourself, why do we have huge lighting problems in terms of energy if 80% of our building stock can use daylighting for its primary illuminant? So it's kind of an interesting culture that we live in, that our buildings can be predominantly daylit. We shouldn't be having a lighting problem. And you don't really, I shouldn't have had to come here yesterday because we should have been lighting our buildings efficiently already. And so it turns out to be a really significant type of problem area to work in. And again, most spaces, be it commercial, residential, hospitality, most of these buildings can use daylighting for its primary light source. And so I really look at daylighting as the primary light source. I mean, this is and it should be a light source of preference, and it should be a light source that we use first before we use electric lighting. And again, we talked a little bit about this yesterday, but daylight, fairly narrow part of the electromagnetic spectrum. Looking at it just as a light source, it has admirable qualities. First, it's a very continuous spectrum. It's very smooth. It's not spiky. It has color constituents in all spectrum, meaning whatever color you might have, it's going to be rendered very well. Whatever color you might dress in, it'll look good. And when you look in the mirror, you'll look good. So it's an excellent light source for interior spaces. Daylighting has lots of different characteristics. It could be very warm, like sunsets, like yesterday's sunset. It can be very cool, but it has always the same general characteristic. It has a relatively continuous spectrum. It's relatively smooth, and it provides excellent color in all spectra. Okay. And so if you want to sort of look at sort of relative to the other spectra that we use inside buildings, I'm showing daylight relative to fluorescent. And fluorescent is a very large departure in quality, very spiky, discontinuous, and doesn't provide color equally in all wavelengths. And so we have the concept of correlated color temperature as well, and daylight comes in a whole range of correlated color temperatures, and this is relative warmness or coolness of a light source. And so I'm showing here a whole range of different kinds of coolnesses and warmnesses, all the way from from blue sky, which could be 20,000 Kelvin, all the way down to a candle, which is about 1800 Kelvin. And so here I'm showing a whole range of electric lights in a range of warmnesses and coolnesses that typically get used inside interiors. And this matches the